Today I'm going to talk about green accounting. I'm going to mostly talk about green accounting at the national, the country level, both theory and practice. At the end, I'm also going to talk about corporate accounting. I just think that there's a lot less to say about that. This is where we are in the sequence. This is the very final lecture. This is the very final week of lectures and seminars of this term. Some of the stuff that I'm going to do today is a bit more technical than what you're used to. The really technical stuff won't be examined. One of the reasons that I do this, I think it's important, obviously, but also to give you a taster of what it would be like should you do a master's in economics, right? Where the material that I'm going to show would be everywhere, essentially. I'm going to start a brief recap of gross domestic product and what is wrong with it. And I'm going to talk about the environmental product in theory and then in practice, but with a detour around productivity growth. I'm going to talk about genuine savings and other alternative indicators. And then, as I said, as time permits, I'm going to talk about corporate accounting towards the end. I don't know why it says production here. Gross domestic product is the measure of economic performance. This is what everybody always talks about GDP. It is used to track the economy over time, and if you normalize it with the number of people in a country, it is also used to compare economies with one another. It is the indicator for economic performance. GDP was designed in 1925 by the man you see displayed here, Simon Kuznets. And Kuznets, already 7 years later, wrote about the dangers of GDP. He wrote that the welfare of a nation can scarcely be informed from a measurement of national income. GDP was always meant as a measure of economic activity, of what is going on in the economy, not how well an economy is doing or how well the people in an economy are doing. That is not what GDP was designed to do, but that is what everybody uses GDP for. It simply measures all the transactions in the economy, or rather, there are three alternative ways of measuring GDP and defining GDP. One as the sum total of consumption, and not just consumption by households, but also investment by companies and consumption by government. And if you add up all expenditure and all consumption, you have GDP. Alternatively, you can add up all value added in the economy, and then you get to the same number, of course, bar some statistical issues, or you could add up all income in the economy, and not just wage income, which is what we typically think of as income, but also profits, that is capital income, and of course what the government takes. And then of course you need to correct that for changes in the capital stock as well. And if you do that, you also end up with theoretically the same, in practice roughly the same number, right? So those are the three ways of thinking, of measuring GDP. Those are also the three ways of thinking about GDP. It's total consumption, total income, or total value added. And that's what it is. Not less. This is actually very useful to know, but also not more than that. The problem is that some economists and almost all non-economists think that GDP is the be-all and end-all of measuring the well-being of a nation. It's just not the case. And one of the more eloquent critics of GDP is RFK. Too much and for too long we seem to have surrendered personal excellence and community values in the mere accumulation of material things. All these things are just not in GDP, right? They are just not. And there's a long list of things that are missing or that are wrong. The first critique of GDP is that it includes investment, which is an expenditure, which is a form of consumption, you could say, but not depreciation of the capital stock. And that immediately leads to Bastiat, who you see here, and his broken window fallacy, where essentially if you break a window, that's not an economic transaction. It's the destruction of a capital stock, but you don't count changes in the capital stock in GDP, so that doesn't matter. But then when we repair the window, that is an economic transaction. You get a new pane and you pay somebody to put it in. So those are two economic transactions. So breaking a window increases GDP, right? Which is just silliness. Because nothing has gotten better. You could argue that things have gotten worse because you needed to spend money on something that you did not want to spend your money on, right? You'd rather buy something nice than a new window, had the window not been broken, right? The solution to this is the so-called net domestic product, which is essentially GDP minus depreciation. So that is a simple extension. The problem is that NDP is much more difficult to measure than GDP. So typically we have data for GDP, but not so much data for NDP. The other limitation of GDP is that we are talking about economic activity. It's supposed to be a measure of all economic activity, but actually it is a measure of all economic activity in the market. And everything that is outside of the market is not in GDP. And that goes for cleaning your house. In olden time, economists were allowed to be openly sexist. Now we are much more coy about that. And the best way of increasing GDP was, or the best way one way of reducing GDP, as economists used to joke, was to marry your housekeeper, right? Whereas a housekeeper is an economic transaction, but then you marry your housekeeper, so you no longer have to pay her, but she keeps doing the work, right? And this is the olden times. That you see a drop in GDP, right? Because what used to be an economic transaction now becomes labor that is supplied for free, right? Subsistence farming, if you eat the produce of your fields rather than selling it on the market and then buying on the market what you want to eat, then that doesn't count towards GDP, right? All sorts of things are included that are actually not good for us. And in week 7 or week 8, week 9 even, week 8, we talked about defensive expenditure. So buying an air filter or buying bottled water rather than drinking water from the tap. That is a market transaction. That counts as something that is good if you look at GDP. But of course, we would rather have been able to drink the water from the tap. We would rather have been able to go around without an air filter, right? Criminal activity is not in GDP because it's illegal, right? So it's not counted as a market transaction. anything that's going on in the black economy is not included. And of course, and that's the subject of this module, anything that goes on in the environment that is not in the market is not in GDP either. And then of course there's all these other issues that are not in any utilitarian ethics, such as freedom or the distribution of income. All that is not in GDP, right? So, as I said, this measure was designed almost 100 years ago, and almost 95 years ago it was realized that, yeah, this is not quite what I had intended, guys, is what Kuznets essentially wrote. And people have come up with all sorts of alternatives and extensions, and that is what we're going to talk about, focusing on the environment, of course, but a lot of these things extend to the other omissions and criticisms of GDP just as well. So I'm going to start with a little bit of theory. The question is how to bring the environment into the national accounts. And I'm going to look at the environmental net domestic product as the theoretically correct construct. So GDP is essentially all expenditure, right? So be it expenditure on consumption or be it expenditure on investment. I'm just going to assume that those are the two categories. Of course, there are more, but let's just say that GDP is consumption plus investment. Then NDP is consumption plus investment minus depreciation. The window that you broke, right? It needs to be subtracted. That is the net domestic product. Now the environmental domestic product is the net domestic product, consumption plus investment minus depreciation, plus something that is here called P, that is our enjoyment of the environment, the sort of intangible consumption of environmental amenities. And of course, if you have a bad environment and you're not enjoying it much, then P is negative, right? But let's call it positive for the moment. And then we subtract the degradation of the environment. All the forests that have been cut down and so on and so forth are subtracted. And then we have the environmental domestic product. Now, where does this come from? And this is the technical bit that I promised. If my computer wakes up. There we are. I'm going to talk about the welfare significance of the national product first, and then I'm going to extend it to the environment. And this is work done by a young Marty Weitzman. As you can see, he was quite cocky, quite young, and it only got worse when he got older. So we want to maximize utility, but we're not interested in just today. We want to do this over the indefinite future. So we want to maximize utility. Utility is a function of consumption C. Consumption C is the decisions that we make, and then we're looking at the net present value of this. Now, I'm doing something peculiar here. You're familiar with net present value. That's the sum of the utility in all periods times or divided by 1 over 1 plus r, 1 plus rho to the power t, right? That is what you're used to. But here we have an integral. But you recall from your calculus that an integral is just a summation over very small steps, right? If you sum utility of today and then a year from now and a year from a year after that, sum that, you have a summation sign. You do it in discrete periods, but why would you do it in steps of 1 year? You could do it in steps of 1 month or 1 week or 1 day or 1 hour or 1 minute or 1 second. And if you take infinitesimally small steps, how I should say it, infinitesimally small steps, then the summation becomes an integral, right? Also, what you should recall from your calculus, if you take the function 1 over 1 plus rho to the power t, and you do that in ever smaller steps, then this thing converges to e to the power minus rho t, right? So what you're looking at here is just the net present value, but instead of discrete time steps, we do it in continuous time steps, or we do it in continuous time. There's no steps here. So this is just the net present value, right? There's a reason that I do it like this. And I'll come back to that. And then, of course, this is not an unconstrained optimization. This is a constrained optimization. We are subject to the evolution of the capital stock. So the K dot that you see there is the change in the capital stock. So it's dk dt essentially. And that is equal to the investment that you put in and the depreciation that you have, right? So minus delta K is how much capital you lose, how much you depreciate, and IT is how much new capital you form. So that is the change in the capital stock. There's another constraint that I just substituted in here, and that is that our total income is a function of our capital stock. So I is, of course, there's actually two constraints here. One is that Y, total output, equals C plus I, right? Which immediately implies that I is Y minus C, right? So that is what you see here. And then the second thing that I substituted in is that our total production is a function of the capital stock that we have. So investment then becomes our production function, Q, minus how much we consume, right? So now we have a complete description of this economy. We have one factor of production capital, we have one consumption good C, and we want to maximize the net present value of the utility of our consumption. Now we have a problem because nobody, I think, has ever taught you how to solve a problem like this. You are familiar with the Lagrangian optimization under constraints, but that does not work for a problem like this. Actually it does, but it gets quite hairy. But if you really deeply, truly understand Lagrangian optimization, then you realize that you can rewrite a problem like this in the Hamiltonian form. So in order to find the optimum of a problem like this, an optimization problem in continuous time, you need to form not the Lagrangian, but the Hamiltonian. And that is what you see here. So the curly H is the Hamiltonian, after Mr. Hamilton, who came up with this. And the Hamiltonian is actually simpler than the Lagrangian. This is the current value Hamiltonian, and that is simply your objective function, but without all the weird stuff. So we do away with the integral sign, and we do away with the discount factor, actually, and we just take our utility function. It's actually a good bit simpler already. And then instead of rewriting the constraint as an equality, as you do in Lagrange, you just take the left-hand side of the constraint, that is the K dot, and you multiply that with its shadow price. But because we are now in Hamilton's world, we call this a co-state variable, but it's just the shadow price. So the Hamiltonian is very simple. It's just the current value of the objective function, uc, plus the shadow price lambda times the left-hand side of the constraint k dot. Right? You can show that this is equivalent to Lagrangian optimization, but let's not do that. It would really take me at least an hour. So we have the Hamiltonian, and now we also have first order conditions, just as you have with Lagrange. And the first order conditions, the one is familiar and the other is a bit weird. The familiar first order condition is that the first partial derivative of the Hamiltonian to the instrument, the control variable, the thing that we decide on, that's consumption, how much to eat, the h, the c should equal 0. Right? That's just Lagrange. And if we do that, then we have the first partial derivative of u to c, so marginal utility. K dot does not depend on c, so that just drops out. Oh, no, I'm lying. K dot is linear in c, right? So it doesn't drop out, it becomes 1. Or rather, it becomes -1. So we have as the first order condition that marginal utility should minus the shadow price should equal 0, or the shadow price should equal marginal utility of consumption. Right? This is the so-called static first order condition. And then we have a dynamic first order condition, and that is that the change in the shadow price, lambda dot, minus the discount rate times the shadow price, rho times lambda, should equal the first partial derivative of the Hamiltonian to the capital stock. And this is a differential equation, and differential equations are very hard to solve. But fortunately for this particular problem, we don't need to solve the differential equation. We can just leave it as is. Now, what we have here is actually the reason why you do this in continuous time with the Hamiltonian rather than in discrete time with the Lagrangian. The good thing about the Hamiltonian method is that it splits the first order conditions into a static condition and a dynamic condition. So the first equation that you see here says, well, this is how things should be today. And the other condition says this is how things should evolve over time. But we're only interested in measuring current well-being, so we can actually ignore the second first order condition, right? Well, the big conceptual difference between Lagrangian, or the interpretation of Lagrangians and Hamiltonians, is that in the Hamiltonian you split your first order conditions into static conditions and dynamic conditions. Whereas in Lagrangian, the two just mix together and can't be neatly separated. So what have we found, or rather what did Weizmann find? So what we know is that the Hamiltonian that was u of c plus lambda times k dot, we know that u sub c, first marginal utility, equals lambda, so we can plug that into the Hamiltonian. And what we have is that the Hamiltonian is utility, current utility, plus marginal utility times the change in the capital stock. Now we can linearize our utility function. Locally, any function can be approximated by its argument times its first partial derivative. So u of c is approximately equal to marginal utility times c, right? This is just the first order Taylor approximation. And then what we can do is bring our marginal utility to the other side of the equation, divide both sides of the equation by marginal utility, and then what we have is that our our rescaled Hamiltonian is consumption plus investment minus depreciation, right? Consumption plus the change in the capital stock. This is net domestic product, right? What I've just done is, rather than posit net domestic product, I've given you a first principles derivation of the net domestic product, right? That is what I just did. So along the optimal path, the monetized, linearized Hamiltonian equals the net domestic product. So now we have an interpretation of the Hamiltonian, and we have a welfare foundation for the net domestic product. So that was young Weizmann, a much older Weizmann. Come on, you can do it. My computer just keeps freezing. There we go. A much older Weizmann. Come on now. Introduced environment into the whole thing. Weizmann, when he was young, was interested in Marxism and those sort of things, and it was only much later that he became interested in first energy and then the environment. So we care about nature now. So in our utility function we add a term n. That means that we also gonna spend some money P on nature conservation, and that of course comes from our budget constraint, right? That is real money that we spend. So the evolution of our capital stock changes, right? K dot is the same as it was, but now we also need to subtract the money we invest in nature, because that does not go to our physical capital stock and it does not go to consumption, right? But of course that money does something good. The stock of environmental amenities that we care about also has its own evolution. The change in the natural capital stock is the natural capital stock that we had times some parameter theta, which could be seen as natural depreciation or natural growth of the environment, plus P, that is how much we spent in improving it, right? So we form the Hamiltonian, right? And the Hamiltonian is, the current value Hamiltonian is just our utility function. Do away with the integral and the discount factor. Plus the shadow price times the change in the associated capital stock, so lambda K dot. Now we have two capital stocks, right? We have K and we have N. So we also do the shadow price of nature, we call that mu, and we have N dot there, right? It's again the right hand side of the left hand side even of the constraint. Two control variables, two capital stocks, so we have four first order conditions. The first two first order conditions, static and dynamic, for physical capital are as they were, and we have additional first order conditions for the natural capital stock. So the dynamic first order condition is again as it was previously, the change in the co-state variable mu dot minus the discount rate times the co-state variable, rho times mu, should equal to the first partial derivative of the Hamiltonian to the associated capital stock, dh dn. We're going to ignore that, right? We're only interested in the static conditions. The static condition is we need to take the first partial derivative of the Hamiltonian to n, no, to p, sorry, because p is what we do. So n, u depends on n, and n depends on p. So we have u sub n, the first partial derivative of utility to nature. So this is the marginal value of environmental quality. But we need to apply the chain rule. Also, how if we change our expenditure on environmental protection, or if we spend money on environmental protection, how much does the environment improve? That is the NDP, right? And the same for the mu. Yes, the same happens for the mu, because that doesn't directly change with because that depends on that relates to n dot, right? So again, you need to do the n dp, the chain rule. It looks a bit more complicated than it did, right? So now we're going to plug it all. We're going to follow the same rule, and we're going to plug it all back into the Hamiltonian, because that is what we did on the previous slide, right? So let's do it again. Really, the change in the Hamiltonian previously with the previous slide is that now we have n times n dot, right? But we know mu, I should say, times n dot. But we know from the static first order condition, the second one that you see here, that u sub n minus mu should equal 0. So we can replace the u sub n with a mu, right? So that is the first thing that is going on here. And so we got rid of the shadow prices, right? Which is handy. And now we need to linearize the system again. So u of c becomes u sub c times c, right? Linear approximation of utility. You see k dot remains the same. Then we need to do the same thing with the utility we derive from nature. So we replace u of n with the marginal value of nature times the amount of nature that we have. That is un times n. That is this term you see here. And this term we just leave as it is and plug it in there. And then we multiply this thing by 1. And 1, of course, equals to marginal utility of consumption over marginal utility of consumption. Right? Then we reorder, we bring UC to the other side of the equation again. So again, we have a monetized Hamiltonian. The Hamiltonian is measured in utility. Now we have it measured in money terms. That is C plus K dot, right, as we had before, the net domestic product, plus the amount of nature times the monetized value of nature, right? This is how much nature contributes to our well-being. This is how much consumption contributes to our well-being. So if you take the ratio of the two, we have the relative price of nature in money terms, right? This is what we've been talking about in monetary valuation. Essentially, that is UN over UC. So this is how much we enjoy a good environment, and this is the value of the change in the environment. So we have the net domestic product, the environmental domestic product, right? Some people are looking at me like, well, really? Along the optimal path, the monetized linearized Hamiltonian equals the net domestic product plus the monetized value of nature and its increase or decrease if it's negative. If n dot is negative, if nature deteriorates, then we subtract that, right? So this is what Weizmann did, and it's one of the reasons that he should have won the Nobel Prize. Instead, the Nobel Prize went to Nordhaus. The Nobel Prize for Environmental Economics went to Nordhaus, who you see here. This is the younger Nordhaus. Tobin also is a Nobel laureate, but for something else entirely. And these two gentlemen together in 1972 essentially did the same thing, but in a more ad hoc derivation. And they proposed a measure of economic welfare, which is a measure of consumption and of production. And the measure of economic welfare is again the net domestic product. So we got rid of Bastiat's broken window, but you need to exclude from that is economic bads. So stuff that we do that we actually don't really want to do, like pollution control, like defensive expenditure, like repairs, right? That is not stuff that contribute to our welfare. That is just something went wrong and we are fixing it, or we're preventing it, or we're preventing bad things from happening. They also subtract categorically similar regrettable necessities, so money spent on the police. I don't actually enjoy having the police around, right? It actually doesn't contribute to our well-being. It just prevents bad things from happening, or at least that's what we think the police should be doing. Mrs. Cressida Dick, really you should be doing your job. And then add such things that are actually economic activities, such as housework and the production of cannabis, right? Those sort of things. Add them to NDP, as well as leisure time should also be added to this, because it's also presumably something we enjoy. This illegal production is actually an interesting thing. When countries started, other countries are a bit more advanced than the UK, started legalizing cannabis consumption, and some countries have also legalized cannabis production, that actually leads to a jump in GDP, right? Because what used to be an illegal activity now becomes a legal activity, and therefore GDP increases artificially, and you need to think of ways of correcting that if you're interested in GDP. But in the measure of economic welfare, that was there all along. They call this measure primitive and experimental, but it is still with us, right? And actually, as I showed, Weizmann later defended this and said, yeah, it's actually not primitive. This is exactly what we should be doing. And it looks something as follows. This is much later work by Talbot, Kopp and colleagues. I think this is the United States. The dotted line that you're looking at is GDP. It's real GDP, so we took out, or they took out inflation per capita over the period 1950 to 2004. And what you see is a steady increase. And then instead, or they contrast this with the essentially Nordhaus and Tobin measure of, and they call it GPI per capita, over the same period, where they correct for all these things, particularly for environmental changes. And what you see is that a lot of the progress that we see in GDP really is almost fake. That, yeah, there was a little bit of improvement between 1950 and 1975, but after that the economy, if we measure true welfare rather than economic activity, has been basically stagnant, right? So this is not playing around, right? This is not small things in the margin. These are actually very substantial differences that we see, and I'll have more examples later. All sorts of things wrong with this, all sorts of things problematic with this. Valuation, right? What you need is the monetary value of the environment if you want to add it to consumption, right? And we've been talking about this extensively. Depletion of non-renewables need to be accounted for, and of course the problem there is also technological progress, that we keep on discovering new reserves of stuff that actually work the other way around, right? How do you account for those things in a credible and consistent way? There's the accumulation. It's very easy to do this with flow pollutants. Stock pollutants is much more difficult. There's arbitrary things, right? What expenditure really is defensive and what expenditure is sort of a mix between the two. I grew up in the Netherlands, right, where there's lots of dikes, and you may say, well, had it not been for flood risk, we would not have had dikes, so this is a pure defensive measure. But dikes sort of like do double duty as grazing grounds for particularly for sheep. And if you've ever been to the Netherlands, it's very flat, and actually dikes sort of add a little bit of sight to an otherwise featureless landscape, so people actually enjoy the view of these things. So do we count this as a purely defensive expenditure? Oh no. Do you include inequality in this measure, and if so, how to measure it and how bad is it? And that makes it sort of a measure that can be massaged upwards or downwards depending on the intentions of its use. Final thing I need to say about this, going back to the very first lecture, we are adding environment to the economy essentially. So we assume substitutability, right? So this is a measure of weak sustainability, not a measure of strong sustainability. And some people may object to that. I need to speed up a little because I'm only in chapter 3 of 7 and halfway through the time. So what goes wrong if we mismeasure economic output? What happens if we look at a standard measure of productivity growth and we do this with and without the environment? And again, this is a little bit technical. So how do we measure productivity growth? Well, the standard way of doing this is to consider the following example. So we assume that there's two input factors to production, Y, labor L, and environment E. And we assume a production function F, and we have total factor productivity A. So total output is simply production function times total factor productivity, and the production function has two attributes: the amount of labor that goes in and the amount of environment that goes in. We're not interested in production, we're interested in the change in production. We're interested in productivity growth and how to measure that. So we're interested in changes, so we let all variables change by a little bit. So A becomes A plus delta A, and L becomes L plus delta L, and E becomes E plus delta E, and as a result Y becomes Y plus delta Y, right? Then we're again going to linearize this system, and the F of the new L and the new E is, first one, the Taylor approximation, the old position, right? plus the change in L times the first partial derivative of df of production to L, right? And the slope of the production function in the environment as well, right? So this is again a first order Taylor approximation. So if we do this and we substitute this thing to here and take away, subtract y, then what we have is that the change in production, dy, is approximately equal to the change in total factor productivity, delta A, times our old production, f of L and E, plus the slope of the production function in L times the change in L, plus the slope in of the production function in E times the change in E, right? So that is what we have. Then we divide by y to get to a proportional change, and now we have a growth rate. We find the expression that we have there, that the change in total production dy over y equals the change in total factor productivity plus the change in labor, dl over L, times marginal production of labor times the labor share in output, L over y, and the same for the E, EY times the marginal times the rate of change. Then we're going to impose a equilibrium condition, namely that the price of labor is equal to the price of output times the marginal productivity of labor, right? So this is the one of the three conditions for efficiency, and this is production efficiency, right? That's the condition that we impose in a market economy. So that implies that the FDL is the price of labor times the price of consumption, and no, the price of labor divided by the price of consumption, right? We substitute that in. So L over y, the FDL times the LL, we can replace the FDL by the marginal price ratio, and the price of output is of course equal to the price of labor times labor plus the price of environment times environment, right? And then we redefine this thing cost share SL of DLDL, DLL, sorry. Substitute that in, and what we have is that the change in total factor productivity, dA over A, is the change in output minus the change in labor inputs times the cost share in labor inputs minus the change in environment times the cost share of the environment, right? And then we can we can change notation as this is a a growth rate, right? So the growth rate of productivity is the growth rate of output minus the growth rate of inputs times the cost shares of those inputs, right? So that is how we measure productivity change. And somebody should have told you this in macro at some point. Now, the problem with this is environment is elusive, right? We find it very difficult to measure this. So let's assume that instead we measure labor inputs but not environmental inputs. So we assume that we have a production function f that is only a function of L. And that of course means that we're measuring A star rather than A. We don't measure total factor productivity, but we measure something that is similar to total factor productivity, but not actual total factor productivity. And that immediately means that A star is a biased approximation of A, the thing that we're truly interested in. But it also implies that the growth rate is biased. And by ignoring the environment as a factor of production, we essentially have assumed that it behaves the same as the things that we can measure. So essentially we have assumed that the change in environmental production is the same as the change in labor. The change in environmental supply is the same as the change in labor supply. And if you go back to equations a bit earlier, essentially if E and L grow at the same rate, as L plus as E of course add up to 1, right, because these are cost shares, then essentially going too fast. Essentially what you have is that your change in productivity equals your change in output minus your change in labor inputs, right? But if in fact the change in the supply of the environment grows less, or that the environment grows less fast than labor, so in fact E dot over E equals L dot over L minus B, where B is an unknown constant, then the following happens, right? Then really what we have is that A dot over A, this thing. Then we need to correct, because this is the expression that we have, right? So now we replace SE times E dot over E. You replace that with L dot over L plus SE over times B, right? This is in fact what we have. This is the same thing as we had previously, and now we have to add the term SE times B. Which implies that if environmental productivity grows less fast than labor productivity, that is B is greater than 0, then labor productivity growth understates total factor productivity growth. And this matters, a lot. The guy who figured this out empirically is, I want to say Robert Repetto. I'm pretty sure his name is Robert. I'm absolutely sure his name is Repetto, and this is what he looks like. Did this for 2 sectors. Well, he actually did it for a whole bunch of countries, for a whole bunch of sectors, but let's just look at the United States, and let's look at power generation and agriculture. Essentially what we found is that total factor productivity growth is faster if the environment is included, and slower if the environment, therefore slower if the environment is omitted. And if you look at the bottom graph, for agriculture, it doesn't really make a big difference, it makes a small difference. If you look at power generation, there's actually an enormous difference between the solid line and the dashed line. That by omitting the environment from the calculations, you actually get a very misleading picture of how total factor productivity has changed. And the intuition here is that we've been getting smarter faster than it seems if we ignore the environment, because the economy needs to compensate, or our measure of progress needs to compensate for the very slow growth of one of the inputs, one of the crucial inputs into our economy. So if the environment doesn't improve much or even deteriorates, but it is a factor of production, but we ignore it in our output measures and our input measures, then it seems as if we're not progressing very fast. But if you include this sort of drag on the economy, deteriorating environment, then it actually turns out that technological progress has been much faster than it seems, right? Is that intuitive to people? If you sort of forget a handicap, you sort of like see that somebody is running ever faster because he or she is training a lot. You can just take that as a raw measure. But if you ignore that there's actually a drag on this, that this person who's, say, running the 5 kilometers once a day, and you see that he's going faster every week, right? Well, this is progress. But if you ignore that there's a drag on this, namely that he also put weights on his leg, heavier weights every week, so as to increase muscle strength, and you just measure the times but ignore the weights that he puts on his leg, then you actually understate how much quicker and how much stronger he is getting, right? So that is essentially what is going on here. We ignore a drag on the economy. We see the economy is progressing, so we think we're doing great, but if we ignore the drag on the economy, we're actually doing better than if we include this drag, right? So that is what is going on. Right. I got half an hour left. God. I don't think we're going to get to corporate accounting today. So this is where we are. So this was all the theory. Let's look how the Office of National Statistics does this. The Office of National Statistics collects the official accounts, sometimes for the United Kingdom, sometimes for England, sometimes for England and Wales. Let's not get into that stuff, right? Most of this work is for the United Kingdom, or so they claim. So theory is this is what we should do, and this is why it matters. The Office for National Statistics publishes 2 sets of environmental accounts, one known as the environmental accounts and the other known as the natural capital accounts. And then I have a bunch of experimental stuff going on as well. The environmental accounts are worth looking at. I won't take you through everything because it is lots and lots and lots of material. But it's also incomplete. So they look at emissions to air. Water doesn't matter, soil doesn't matter to the ONS. There is a heavy emphasis on anything that has to do with energy. Carbon dioxide is of course a political priority. This is climate change. And then once you've done all this for carbon dioxide, it's very easy to look at other pollutants that come out of energy. Of course, the ONS is not supposed to follow political whims that much. They have materials, data on particulates, they have data on heavy metals, and that's what I'm going to show you. They also have data on how much we spend on protecting the environment, not just how much does the government spend, but also how much do companies spend. They have data on tax revenue for the environment, and they have the material flow accounts that I will also show you. The environmental accounts have no valuation whatsoever. Everything is in physical units. So this is what they look like. And as I said, I won't take you through everything. So if you're interested in vanadium, which I think how you should say this word, then you can see by year 1990 to 2017, probably now updated to 2018 or 2019, by sector, how much comes out of agriculture, how much comes out of manufacturing, and so on and so forth. And that is pretty detailed. So they have it for the gross sectors, that is the letters that you see at the top, and then there are 21 sectors, but they also have it for the detailed sectors, and then you have something like 100 or so economic activities, and you can see the vanadium emissions for all of these. Now you may wonder, why do you care about vanadium? Because it's toxic, right? So vanadium is a heavy metal, and vanadium is the thing that makes these mushrooms toxic. If you eat these things, you'll die, and the reason is very simple: there's vanadium in this, right? So we should care about this. And they do this for not just vanadium, but for a whole range of pollutants, right? So if you want to know how much of the stuff is in the UK environment and where does it come from, this is of course the first question you should ask is, I want to get rid of this stuff, who should I target, right? You can see that if you were worried about vanadium in the year 1990, then a lot of it comes out of the transport sector, a lot of it comes out of manufacturing, a lot of it comes out of power generation, very little comes out of real estate, right? And if you know something about these things, you say, yeah, that's logical. They also have data on tax revenue. So this is who pays environmental taxes and how much is it. In the year 1997, it was about 24 billion pounds were paid in environmental taxes. That went up to almost double, 50 billion in the year 2016. And you also see between those years a shift in the composition of environmental taxation. In 1997, more than half of it was paid by households. In 2016, less than half of it was paid by households. And you see a very sharp increase in environmental taxes paid by services, by transport, no, not so much by transport, by industries, right? So that is useful data if you want to know what do we do with regard to environmental protection in the UK. They also publish the material flow accounts, which look like this, and this is measured in kilograms. This is how many tons of crops were produced, how many tons of wood were produced in every year, how many fish were caught, weight, right? Not in value, in weight. Metal ores, how much gypsum was mined, and so on and so forth. All that can be looked up. This is domestic extraction. This is the same, but now for imports. So how much of the stuff came from abroad to our shores, and they have exports as well, how much of the stuff. And this is stuff, right? This is not value, this is not volume, this is weight, how much of the stuff was exported. So this tells you something about how does the economy interact with the environment. Then they also publish the natural capital accounts, which is a different team within ONS that does it. And now they're looking at what does the environment do for us, essentially. And they do not follow the total economic value classification, but instead they follow the services classification. So what does the economy do for us? And they split it up, as I explained 5 weeks ago, into provisioning services, regulating services, and culture. And here everything is monetized. So this is provisioning. This is essentially stuff that we extract from nature. This is a time series and everything is added up. The red things you're looking at is fossil fuels. So that is a extraction, that's provisioning by nature, right? It gives us stuff to burn and keep our houses warm and make electricity. And what you see is that in many years this was the big one, but then in later years, because the price of oil collapsed, it actually became very small, and of course production in the North Sea is declining as well. And in 1998 the guys actually operated at a loss there, right? So we lost money. You also see the total value of agriculture here and fisheries. And if you're a Brexiteer, you should get very cross now because you can't see the orange, right? And we've screwed over the whole UK economy for essentially to protect, but then not, the little bit of fish that we see there, and so on and so forth, right? So this is what you can see there. Another service provided by the environment is that they clean up the air. And trees in particular are very good at removing air pollution. And what you're looking at here is the amount of PM2.5, the very small particulates that hinder your cognition and so on and so forth, as well as a whole bunch of other, I should look at my graphs, not just at the title, a whole bunch of other pollutants are removed from the environment by woodlands in blue, by crops, and so on and so forth. You see who does the removing, right, and what is being removed. And this sort of shows, yeah, we should not cut down too many trees if we want to keep the air clean, right? So that is what this shows. And then also the value of recreation, and where not the value of recreation. Where do we go recreate ourselves? And to environmentalists, this is a bit of a shock because actually most of leisure time is spent in cities. No surprise if you realize where people live, and what most people actually do for recreation is watch television and those sort of things, or go to the gym, and most of that is in towns and cities, right? So that is where you spend most of your time. We're now already at figure 33, right? So I skipped lots and lots and lots and lots and lots of information. And then also now we are putting a pound value on this. How much do we actually enjoy this? And the graph here is a little bit different. People actually do not spend a whole lot of time in coastal margins, that's the origin. But if you then put a pound value on this, then that actually increases, because people enjoy being on the beach more than they enjoy being in town, if these numbers are correct, right? So this is what happens in practice. This is what the Office for National Statistics does. And it's very different from the theory, right? Very different from the theory. But this is what they think they can do with the data that they have. I'm not going to do corporate accounting, no way. I can do all this in 20 minutes. I need to talk about genuine savings, because that is what the World Bank does. And like it or not, The World Bank is a dominant data provider and does this across countries in a consistent way. Now, the genuine savings indicator isn't that much different from the environmental domestic product. It's essentially the first difference of the environmental product. Essentially, genuine savings is environmental product this year minus environmental product last year. They used to call it genuine savings. Nowadays, it also comes under the name of adjusted net savings. And the big driver of this is the guy you see here, Kirk Hamilton. And essentially, it's, as I said, the measure that the World Bank uses. Genuine savings is defined as net investment in manufactured capital, so that's investment minus depreciation, right? That's what the word net means. Then the net depreciation of natural capital, or the net investment, but they call it net depreciation, so they subtract it, right? So this is how much the environment has changed. And then they also add the net investment in human capital. And essentially this measures how much our capital stock, the total capital stock, not just physical capital stock, has changed. And this is immediately a measure of sustainability, right? If genuine savings is smaller than zero, then essentially we're losing capital, right? We lose future production possibilities. And if genuine savings is greater than zero, then we're weakly sustainable, right? Because we're still adding up. We assume that physical capital, manufactured capital, can substitute for natural capital. And physical capital can substitute for education, right? So this is the theory, but this is what they do in practice. And it is very, very, very limited. So in the UK national accounts, you find data on vanadium, right? World Bank, no. It's fossil fuels, minerals, forests. That's it. Nothing else. Health, damage to health only includes PM10. Not the NOx, not the SOx, all those things are ignored. And investment in human capital, is only formal education in schools, right? So, and it's the expenditure on education, not whether that expenditure actually goes to teaching people something. And the education that people do at home is ignored. The education that people do in companies is ignored, right? So it is very limited. Nonetheless, it is useful. For some reason, I have an example of Bolivia in the year 2003. So the gross savings were 12% of the gross national income. Then if we take away depreciation of fixed capital, that falls to 2%, 2.5%. If we add education expenses, it goes up to 7.5%, which is good. But then if we take away the depletion of natural resources, which in Bolivia is, I think, a lot of timber and oil, and actually falling. We're actually not doing that well. We're actually depleting their natural capital, right? And then if you add the damages from pollution, Bolivia is actually losing natural capital, right? So if you look at, that's why I picked this example, I guess. So if you look at your GDP measure of savings, Bolivia is doing great, right? They invested 12%. If you actually include everything, well, everything that can be quantified, and they actually lost 4%. They're actually getting worse off in terms of future production potential. So this is not good, right? Now, as I said, the reason that you're interested in this is because the World Bank does it consistently over time for many countries. So you can draw pictures like this. You can compare parts of the world where in the sort of at the top you're looking at the dots. That is East Asia, right? Has been doing great. At the bottom you're looking at North Africa and the Middle East, where you actually see that people have been taking away from their natural capital, right, and from their total capital. Essentially all the increases in consumption that you see, or maybe just in some parts of Africa, stagnant consumption comes at the expense of their capital. They're essentially eating the production of their children, right, is essentially how you should read this. So this is a useful thing to look at, and then you cannot just compare it over time, but you can also compare it between countries. At the very top you see Sri Lanka is doing great. This was 2016. Denmark is doing fine, and so on and so forth. At the very bottom you're looking at countries like Mozambique, Timor-Leste, Liberia, where Liberia actually is 80%. 80% of consumption is essentially eating up capital, is how you should read this number, which is a very scary number, right? A very scarily big number. So that is what these numbers can tell you. There's also lots of things that these numbers cannot tell you. So there's all sorts of things missing. Fisheries is not there, soil erosion is not there, water pollution is not there, diamonds are not there. There is an experimental project in the World Bank to start including all these things, but it isn't ready for prime time consumption yet. Human capital does not include depreciation, right? Not just the death of well-educated people, but also the slow deterioration of skills that we used to learn and we used to teach that are no longer valuable, right? Because technology has changed. Also the quality of education is not included, or the lack of quality of education. One of the things I regularly talk about my kids, my son is in primary school, and some bozo in government has decided that kids need to do their timetables and need to do them very quickly. And most of the sort of like tests that they do at 11 is about how quickly can you multiply two numbers in your head. As if that is a useful skill, right? The useful skill is how quickly can you get your phone out of your pocket and do the calculation on your phone, right? That is a useful skill, not to do this in your head. That used to be very handy, right? Before there were calculators everywhere, that is when I was young, it was very handy to be able to multiply two numbers. It's completely obsolete skill, almost completely obsolete skill now. Social capital is not in there, and as I said, for many things what they measure is how much money you pour into something like education, not what you actually get out of it in terms of improved capital. So lots of things left to be desired, but they're smart people and they're working hard to improve this. 8 minutes, 7 minutes left. No, that clock is actually a bit fast. 9 minutes left. To talk about the ecological footprint. So I started with GDP and what is wrong with it. and then told you how to do it. That's the environmental domestic product. Genuine savings, which comes close, but is not the most popular one. There's a whole bunch of people who have come up with alternative indicators. One that is extremely popular for reasons that completely and totally escape me is the Human Development Index. And Human Development Index is essentially an average of 3 indices: GDP per capita, economic activity, life expectancy at birth, and an education indicator that is 2/3 of the adult literacy rate and 1/3 the enrollment rate. And then you have a problem because you have 3 things that you cannot compare and you need to add them up. So the way they do this is that they scale each of the individual indicators from 0 to 1. So the highest GDP per capita becomes 1 and the lowest GDP per capita becomes 0, and then you linearly interpolate everything else or scale everything else. And then what they do is just take the average of the 3. So essentially they say that these 3 things are equally important and can be made commensurate like this by taking, essentially rescaling everything with the min and the max. It's a very strange thing to do if you think about it. GDP per capita, for instance, there's a few countries on the planet which are exceedingly rich, right? So Luxembourg is one, Bermuda is another country that is very, very, where the average person is very, very rich, and the reason that Bermuda is so rich is essentially because it's the playground of rich Americans, right? That's why the per capita income at Bermuda is so very high. And the same is true for Luxembourg. They essentially removed all the poor people from the country, and now it's just the playground for bankers, and that is why Luxembourg is so extremely rich. So your maximum is essentially determined by an outlier country, right? And everybody else gets scaled down, and the real differences in income at the bottom, because you divide everything by how rich Luxembourg is, gets smaller, right? Whereas life expectancy, you don't see these outliers because this is just human biology. That, yeah, you have medical things are much more standardized. So these differences in income get suppressed because economic processes allow you that there are a few outlier countries, whereas biology does not allow you for outliers. And even in Japan, where a lot of people live to 120 or 130 even, it's still a fairly small group, and they increase the average, but not by a whole lot, right? So you get a much bigger spread. It doesn't make any sense to do this, but a lot of people like the Human Development Index because data are readily available, and it sort of sounds cool, right? Another very popular measure is the ecological footprint. I'll talk about that in a minute. And another one that I found amusing is the Happy Planet Index, which is, for reasons I do not understand, life satisfaction times life expectancy divided by the ecological footprint. And I won't take you through the numbers, but here you're looking at some of the results. So the countries that are happiest are Vanuatu. Colombia comes number 2. Colombia, the second happiest country in the planet? Really? Like, the chance of getting shot or kidnapped in Colombia are actually very, very large. There's enormous poverty in large parts of the countries, but apparently that doesn't care. Cuba, right, is number 6. Yay, let's all move to Cuba and get our political rights taken away. It's just a strange thing to do. If you look at some of countries that you're familiar with, the UK ranks number 108 below Libya. Right. Now, who wants to move to Libya? Nobody, right? A country that is torn apart by civil war, enormous poverty, very low standards of living. This is not how you want to construct. I mean, you should construct indices the way you want, but you should look at it and say, well, does it actually make sense, right? Does it actually make sense that Libya is a happier place than the UK? The ecological footprint flows into the Happy Planet Index, and it's an important one because it's very popular. There is I don't like it, there is a video by the guy you see to the left, that's, now I forget his first name, Wackernagel, where he defends what he's doing. So I suggest that you watch that and do not just listen to me. The ecological footprint is essentially, it's a measure that tries to measure strong sustainability, that does away with the substitutability of natural capital and physical capital or manufactured capital. And as the name suggests, it essentially translates everything into a measure of land area, with the idea that we have only one planet, we have a finite amount of land on the planet, and therefore we can translate everything into the land required. So what they try to measure is how much land do we need to produce what we want and to get rid of all the waste that we produce. That is essentially the basic thought. And this is physiocracy, right? This is, everything is translated into land, just like the Carnet did. The way it works, and sometimes it is very useful, right? If you're looking at the demand for timber, for instance, how much forest do you need? How much forest area do you need? If you're looking at demand for food, is how much land do you need to grow that food? If you're looking at space to live, how much area do we actually take up? That all makes sense. But then if you look at environmental pollution, actually they say climate is the only thing that is important, and then it is about our CO2 emissions, and then the question is, how do you express CO2 emissions in land area? And the way they did it is how much trees should be planted to suck the CO2 back out of the atmosphere, and how much land do we need to plant all those trees. And that matters because if you look at the ecological footprint, it's actually dominated by the gray area, both in absolute terms. It's actually in here it's gray, there it's more blue, it's gray. It's the top one. That's where the dynamics come from, that's where all the growth is, but by now it's also more than half. So the ecological footprint is essentially driven by this assumption of CO2 has to be sucked out of the air by trees, and we need area to plant those trees. And it completely ignores all the other ways you can get rid of CO2, right? So it is strange. What is also shown is the size of the planet. Everything is normalized to the amount of land that we have, that is known as the world biocapacity. And what you see that since 1974 we have been outliving our means, right? We actually needed a larger planet than we have. That is for the world as a whole. This is for individual countries. where essentially they calculate this number and then put it on the calendar. And what you see is that in February 11, Qatar exceeded its biocapacity. It used more land than Qatar has, whereas for Indonesia, it was almost by the end of the year, December 18, that Indonesia started exceeding its capacity. So Qatar and Luxembourg are the bad guys, right? And Indonesia are the good guys here. UK, I can't find the UK so quickly. Oh, May 16. So the it's month 5, right? So the UK, actually what this says is the UK needs more than twice the area to live sustainably. Very strange. I've said these things before, right? It's a very strange thing to do. It's also completely incomplete, right? Environment is basically restricted to climate, to carbon dioxide, not even the other greenhouse gases, let alone other environmental problems. Water is ignored. The overshoot days essentially say, well, you should stay within the limits of your country's area. Kim Jong-il would be proud, right? This is autarky. This is you cannot trade. Trade is forbidden. You should stay within what you have. Really? Do we want to say that? But it is a measure of strong sustainability, right? There is no assumption here that you can do away with the environment as long as you compensate that by a stronger economy. So in that sense, it is applaudable, but of course then within the environment it assumes full substitutability between different kinds of natural capital, right? Because everything is essentially brought down to square meters. So much for today.